I'm Ethan Kwan, and today I'm going to be showing you how these first oceans formed. Now, the oceans are a very special place on Earth. They are the only place we know of in the universe with water. And that's a very important thing because we wouldn't be able to live without water. Now, we have a simulation of Earth in Universe Sandbox 2, and as you can see, the oceans are huge. They are gigantic. So what we're gonna do today is we're gonna explore how these gigantic oceans came to be. And we're standing on an ocean, which is kind of impossible, but anyway. So we are going to look at this Earth, and we are going to, using Universe Sandbox 2, we are going to try and simulate or try and at least get a grasp of how Earth's oceans formed. Okay, so without further ado, let's get started. So, water. The Earth is the only planet that we know of with it, drenching over 70% of the entire planet, which is a lot. Despite its abundance, experts are still puzzled about how the oceans formed. Hey, it looks like it's winter right now. Yeah, it should be. The water could have come in the form of comets, and comets are, well,
this might take a little bit. Yeah, there we go. Okay.
So out here, there are a bunch of asteroids, and these are not exactly asteroids. I'm zooming in on one right now. These are not asteroids. Can't see anything. There it is. And these are not asteroids, they are comets. And these comets are so far away from the sun. As you can see, the sun is just a speck in the in the sky. Can you land on it? Okay, so comets have a lot of water. We can check here. I'm not sure if Universe Sandbox simulates this, but let's just see. Composition, 0 water. Well, it should have some water. It should be frozen. Yeah, solid, it says. Yeah, that was not on purpose. Yeah, so we have, so this is not exactly a comet. This is not a comet. This is more of a dwarf planet, but I am going to be calling it a comet, or I'm going to call this a comet. Well, this says it doesn't have any water, and we can't add any, but these comets, these asteroids that are in the sky, will have a lot of water. These guys will be very abundant in water. And I swapped it for Deimos because Mars' moon, because that other one didn't really show our composition. But here we are. Now, if it's this far out, it should have a lot of water because so far out it should have a lot of water. But it would have taken tens of millions of collisions, and we can simulate this. Where's the Earth? Our home. Let's zoom in. It would have taken tens of millions of asteroids hitting Earth like this. Let's just random asteroid. It would have taken a lot of asteroids. It would have taken a lot of asteroids. A lot. And we can just keep doing this while I talk. So during a period called the Late Heavy Bombardment, late because it was a few 100 million years after the Earth has formed, and heavy bombardment because
the Earth was bombarded with a series of gigantic asteroids, just like this.
And when this was happening, this would not have been a great place for life. This would not be a good place to live at this time. But anyway, while this was going on, these asteroids, it wasn't just asteroids, it was also comets, because the reason for the late heavy bombardment was that, well, I can't really simulate this here. But if we can find Jupiter, there it is, and zoom in, we're on the dark side. Okay, so Jupiter was migrating in, knocking out a bunch of the asteroids from what's called the asteroid belt. And then it was pulled out by Saturn over here. What? No rings? Okay, I can add rings. That's lame. There we go. We added the Saturn rings. That looks okay. Anyway, also, Uranus and Neptune also switched places. It used to be Neptune, Jupiter, Saturn, Neptune, Uranus. Now it's Jupiter, Saturn, Uranus, Neptune. So Neptune crashed into a lot of the Kuiper Belt objects, which is a lot of comets and asteroids, and sent them hurtling in toward the inner solar system. And okay, so a lot of objects were sent hurtling in toward our solar system. For example, a bunch of comets, actually. So if we quickly just shoot a bunch of random asteroids into the inner solar system, then let's aim for Earth. Sorry. There goes a bunch. Anyway, so a bunch of these rocks came in toward Earth and the inner solar system, and it also kind of triggered a major, well, it's called the Late Heavy Bombardment, so, yeah. So Neptune swings out into the Kuiper Belt, crashes into all those objects, and basically takes all of those away with it. So as you can see, a lot of asteroids were just flung out, but some of them did actually hit Earth and the Moon. But Earth is a bigger target out in space, so so the asteroids preferred that. So Earth got hit by a lot of asteroids and also a lot of comets. And could this have brought our water? Well, yes and no. So let me show you why this is unlikely. Okay, so there are two types of water molecules. There is I can simulate this with tennis balls. There is oxygen. There is water, which is like this, with maybe golf balls representing the hydrogen atoms. That's one configuration of water, like that. Or we can have this. We can have tennis ball, but instead of the golf ball, we have one golf ball. Normally we have two, and we have one basketball. And the basketball here is representing the deuterium atom. Deuterium is when two normal hydrogen atoms come together. So this is a hydrogen, which is kind of big, and here's a hydrogen. It's kind of connected like that. It's kind of kissing. And it's like this, and there is this atom, which is called water, and this atom, which is called heavy water. And this baseball is representing deuterium. And we can play this if we want. It's fun. And the basketball basically absorbed everything. Anyway, that's not the point of this video. Anyway, so on Earth, for every 10,000 drops of ordinary water, there are 3 drops of heavy water. Comets are full of heavy water. This was confirmed when Comet Hale-Bopp flew past the Earth, and scientists were able to measure exactly how much heavy water and water was on the comet. Also, we also had proof from the Rosetta mission where they landed on a comet, and they also confirmed that the comet is basically made of heavy water. So comets are probably not the culprit. Comets are probably not the culprit. If not, then what is? Well, the most likely culprit is asteroids, which is kind of a surprise, right? Because asteroids, like this one, don't have that much water, or so we thought. But what we noticed that asteroids have a surprising amount of water, and this, we have confirmed this by, you can try this out for yourself. You can go out, grab a sample of an asteroid. That's kind of hard. You can go, if you live in Arizona or something, you can go to the crater or something. You can get a piece of asteroid and then put it in. Even crushing it won't work, but you can grab a piece of asteroid and heat it. And if you heat it enough, all the water will evaporate out, and it will be condensating on whatever, like, maybe it's a glass bottle, maybe it's a flask. I suggest using a flask. But yeah, that's very interesting. Yeah. Anyway, so we think that water came from asteroids. But how? When the late heavy bombardment began, asteroids also rained down on the inner planets. This is called the Grand Tack theory. The Grand Tack theory says that in the early solar system, the sun actually had a lot of rocks and gas orbiting it. And this put a drag on all the planets. When planets smashed into all that material, it slowed them down. And so Jupiter started migrating in, because if you push something against something, it loses energy. And if it's orbiting, if it loses energy, it's going to spiral in, right? It also pulls in asteroids and shoves them at the Earth. And then, about 100,000 years after, Saturn forms and pulls Jupiter back out, so it resumes the place that we see today. But that means that, we can check. If it was, if it was all the inner planets that got rained, why don't Mercury, Venus, and Mars have water? They should, right? Because those are also the inner planets. Those also got rained down by Jupiter. So why did Earth hold on to its water, but they didn't? Well, Mercury is kind of easy to explain because because it's the closest to the sun, obviously. And if we try and put some water on it, well, we can if we want, but it's going to be hard because it's so close to its star, and it has so low mass. We can check, we can put it in moons, and it's basically 4 times as heavy as the moon. And radius, we can put this in moons too, I think. Yep. It's only about 1.5 times as massive as the moon. So basically it's the same as the moon. But we can put this in Earths. So this is not even 1 Earth. This is like 5% of Earth. So that also helps release water because it has to hold on to its water. So what happens if it's too close to its star, our star. And as you can see, it's kind of leaking away by itself. So all that is water leaking. But it looks really nice right now, doesn't it? So if we speed this up, all of this water should eventually disappear. Yeah, it's disappearing. 8%. 7%, 6%, 5%, 4%, 3%, 2%, 1%, almost 0%. Here we go. Dum, dum, dum. No water. Yeah, that was kind of sad. Okay. So it lost all its water. Let's see. Oh, there's Venus. Okay. So Venus is right now a hellish landscape. It's covered in, as you can see, our heat here. It's like basically the same all around, and we can cool it down if we want, but it's gonna go back to its original. Or is it? Oh, yep. Okay. So it's again becoming a hellish landscape, and so why didn't Venus hold on to its water? Well, Venus is closer to the sun than Earth, yes? So it got hotter, and it evaporated some water. Water in gas form is an excellent greenhouse gas. It is awesome at keeping heat in. So Venus gets hotter, evaporates more water, gets hotter, and evaporates more water, and well, I think you can see where this is going. So basically, Venus lost all its water, and then all of it went into the atmosphere where it got blown away by the solar wind. Okay, now let's look at Earth. So Earth has all the perfect conditions, but there's one more condition that we have to satisfy, which is, I'll show you. So, okay, so as you can see, Mars has a lot of terrain. It has a lot of river beds, and so it's easy to assume that maybe Mars had water. If you look, there's some channels right here, and there's a big channel right here and here. So basically, it looks like Mars could be suitable for life. It has an atmosphere. It has it's not too close to the sun. In fact, it's farther from the sun than Earth. It's also in the habitable zone. But what about Mars? Why doesn't Mars have water? Why doesn't Mars have water? Well, Mars once, and I'm saying once, Mars once had atmosphere. Water. Well, you have to trust me that there was some water. Hey, what's that? What's happening? No, that's not what I meant. Sorry. That's water. Yeah, that's water. Hey, it worked. Yay. Oh, wait. I still have laser on. Sorry. Sorry, Mars. Perfect. That worked. So now we have water on Mars, and it also has some clouds. That's cool. But why doesn't Mars have water now? That's because of solar radiation. So basically, long story short, the water got blasted away by radiation. And what radiation am I talking about? Well, I'm talking about solar radiation. And that's because Mars does not have an atmosphere. I'm not sure if this... I mean, it does show magnetic field, but I don't know if the water can blast away. It can freeze and stuff, but I don't think it can, get blasted by solar radiation, but just stick with me. Okay, so Mars got blasted with solar radiation in the old days. And the reason... Why doesn't Earth get blasted away like this? Well, that's because of our magnetic field. Our magnetic field is our protector against this solar radiation. And Mars does not have one of these. What am I talking about? Mars does not have a magnetic field to protect itself. Yeah, Mars does not have a magnetic field. So right now I'm just adding water, but actually Jupiter brought us this water, but I can't simulate it right now, so I'm just gonna cheat and add water myself. So Mars does not have a magnetic field. Why? Because how our magnetic field was generated is because of our molten iron core in the center of the Earth. And this molten core is something that just basically gives us a magnetic field. It moves around and it turns around, and it basically gives us the protection we need. So, and Mars does not have this active moving layer of iron. Well, it's called a molten iron core, but so it's smaller than Earth, so so it lost its heat faster, and its core cooled down, and its magnetic field disappeared, and sadly our Mars is red now, and there's a reason why Mars is red. It exposed, so without a magnetic field, Mars got exposed, and the water got exposed to the intense, deadly solar radiation called the solar wind. The radiation split the hydrogen from the oxygen, and the hydrogen is very light, so it escaped into space. The oxygen stayed on the ground, stayed on Mars, but then it got absorbed by the rocks, and that's why Mars is red. That's why Mars is red. It looks rusty, and it is rusty because the intense solar radiation basically blew away. The oxygen basically got absorbed into the rocks, and the rocks oxidized, which means absorbed water, and it basically disappeared. The oxygen disappeared, and it's now in the rocks, and that's why the rocks are red. That's cool. Okay, 4 rocky planets, only 1 got lucky. 1 planet got lucky. And while I'm on the topic of being lucky, there's also something I just learned today. And by today, I mean like maybe tomorrow if you're watching this tomorrow. But anyway, basically, if Uranus and Neptune weren't here, Jupiter would have pulled our Venus from its orbit and sent it on a collision course toward Earth. But that didn't happen, and that's thanks to another rogue planet that's a gas giant. And well, more on that next time. Okay, so thank you for watching this. This is a very I love making these videos. They're really fun to make. They are awesome. So if you want to get this software, go to Universe Sandbox. Just search up Universe Sandbox in your web browser, like Google. And then you can get the full version, like me. It does cost money, but it's worth it, totally. No, I'm not advertising. Okay, so otherwise, please subscribe and press the like button, the thumbs up button if you like this video. If you disliked it, well, hit the thumbs down button. I am not recommending that. If you actually disliked it, please be honest. Yeah, but anyway, thank you for watching my video. So anyway, see you at howtodosolution.com, and see you next time. Bye. How do I stop? Okay, I guess I have to, yeah. Bye. Okay, it looks like it's not responding. The force quit? Oh, never mind. Okay, bye.